make the copper. We can eliminate the sulfur and iron, and the copper is left over, and that's, of course, what we want. It's a hot metal business, to be around hot molten metal, and it takes, you have to learn to do that and live with it, and it takes a special breed of cat, if you will, to do that.
Well, it's every little boy's dream. You got cranes and sirens and trucks and fires and explosions and trains and oh boy, that's just one big toy box out here.
One dictionary defines smelter as any apparatus for smelting, an establishment for smelting, or a person engaged in the smelting industry. In 1971, a Kennecott theater commercial on smelting operations gave thousands of people in Utah a much better understanding of what happens at a smelter, specifically the Garfield plant.
Then, each day, 2,600 tons of this concentrate join 200 tons of precipitate at the division smelter. The reverberatory furnaces, which operate continuously, have two functions. Fueled by natural gas, they liquefy the charge with their 2,800-degree Fahrenheit heat, and they provide a long settling pond for slag separation. They are called reverberatories because the flame is located near the top of the furnace, where the ceiling can reflect or reverberate the heat downward.
From the mid-1970s until the mid-90s, the copper smelting operation went something like this. Copper concentrates containing about 28% copper arrived from the concentrators by rail. After 1987, concentrates from the new Copperton concentrator were slurried 17 miles to the smelter's new filter plant for dewatering. This recovered water was then recycled. Copper concentrate was blended with flux, coal, slag mill concentrate, precipitate copper, and other materials. This mixture was fed into Noranda reactor furnaces that contained a molten bath of iron slag and copper matte. Oxygen-enriched air was blown into the bath to oxidize the sulfur and iron, creating sulfur dioxide and providing a turbulence to help smelt and digest the new feed. At the opposite end of the reactor from where the feed was introduced, the molten bath at 2,200 degrees Fahrenheit was placid. Slag, or iron waste, floated to the top and was skimmed off. It was later processed to recover the copper that came off with the slag. The bottom layer of the bath, the matte copper, was now 73% pure. It was tapped from the bottom of the furnace into waiting ladles, which were transported by overhead crane to converter furnaces, where further oxygenating drove off sulfur and slagged iron to produce 98.5% pure blistered copper. Sulfur gases released during the smelting process were converted to sulfuric acid at 2 on-site acid plants. The sulfuric acid was sold to customers all over the country. The last stage in smelting was refining, which happened in anode furnaces where the copper was again upgraded to 99.5% purity. This refined copper was cast onto a 26 mold wheel. These special shapes are called anodes. The anodes were then shipped by rail a short distance east to the Kennecott refinery for further upgrading and the recovery of gold, silver, and other metals contained in small amounts in the anode copper.
What we're doing is we're taking all the impurities out of the concentrate.
How well we do it, or how much copper we can produce is a function of how well we take care of those things. The iron is a slag, and that's not too big of a problem. The other one is sulfur. We have to capture it, we have to fix it. We make sulfuric acid out of it.
In the anode department, what we do there is we basically take out the remainder of the sulfur and treat the copper.
The first ones were reverbs. They took the low-grade mat out of the reverb, put it in the converters. Now they go into a reactor, goes from the reactors to the converters with a higher grade of mat. And the anodes have been pretty much the same. Smelting has been the same process, you know, forever, but it was just at a more technical part and a higher step of it in the operations. And that's, you still got to extract the metal out of the material, and it's still basically the same.
Crush the ore, we slurry it, we ship it to the filter plant, we take the moisture out of it, we ship it to the reactors, and then through the process goes the anode, out copper bars, refinery, and out. And that's that's about as short as it gets. But it works.
Smelting technology and equipment have certainly changed over the years, but the basics of pyrometallurgical smelting have remained pretty much the same throughout history. And Kennecott's Garfield smelter has quite a history of its own. Designed expressly to smelt Bingham Canyon ores, it was built by the American Smelting and Refining Company, now known as ASARCO, as part of the deal that financed the establishment of the Utah Copper Company. The $3 million smelter, which started up on Labor Day 1906, could handle 500 tons of concentrates a day. It also shut down on Labor Day 1906 because the #1 reverberatory furnace didn't operate satisfactorily, but was quickly repaired. By 1908, the smelter was handling 2,700 tons a day. Capacity just kept growing, and still is. The Greek, Slavic, Swedish, Chinese, and Italian immigrants who were hired to build the smelter lived in tents near the site. Tent Town soon gave way to bustling communities like the gone but never forgotten townships of Garfield and Smelter Camp. Garfield was a true company town, built and operated by Utah Copper and ASARCO. With time, both communities gave way to expanding copper operations. In 1956, Kennecott sold the Garfield homes to their residents and had them moved to other parts of the valley.
But I grew up in Garfield. I've been around since 1939. We grew up as kids over the smelter a lot. We had a lot of friends that lived here, so we were over here a lot. When we were kids, we always used to go out to the beach here and watch them pour the slag pots. They were hot, you know. I never had any desire, really, I guess, to go anyplace else.
As the years passed and the mine and concentrator expanded and added new technology and equipment, the smelter kept pace. The first acid plant was built in 1916. with the first contact acid plant coming along in 1937. During World War II, women did many of the smelter jobs, taking the places of men in the armed forces. The Bingham Canyon mine, by the way, provided 1/3 of the copper used by the Allies during the war, and much of that copper was smelted right here. Over the years, the smelter went through a number of expansions and modernizations and took on different looks. For example, in 1957, the smelter went from a 3-stack configuration to using just 2 400-foot stacks. In 1959, Kennecott bought the smelter from ASARCO for $20 million, completing the self-contained copper production cycle. And by 1963, the smelter was going through some heavy technological changes. Roasters were replaced by green feed reverbs. Car dumpers appeared in the new materials handling system. A 500-ton per day acid plant was built. The converter aisle was expanded and slag trains faded into history. A molybdenum oxide plant, which recovered molybdenum from the copper concentrates, was built at the smelter in 1966.
Remember back in those days, the pigeons flew over the smelter and they coughed. You know?
Yeah, but it didn't kill him.
No.
Rising environmentalism in the 1960s and 70s led to legislation that would forever change the way we produce copper. In 1970, modifications to the 1967 Clean Air Act established new compliance standards for copper smelters. The largest, most expensive smelter modification project to date was announced in 1973. This was a project that would alter the skyline of the Salt Lake Valley. The new smelter was once sarcastically described as a gas cleaning and processing plant that will also produce copper. When the $300 million project was finished in 1978, the smelter was basically brand new. Noranda reactor furnaces had replaced reverbs in a new smelting process. A new acid plant and a slag flotation mill had been built. Advanced gas cleaning facilities were added, and the longest continuous concrete pour in Utah history had created a 1,200-foot stack that dominated the westward view of the valley. It had been a monumental effort that had created one of the largest smelters anywhere, and it was to last 18 amazing years.
It's unique one way because there's no other smelter in this state of Utah, you know. I mean, it's different work than anybody else does, you know. When you're out there in the real world, out in the valley, you know, somebody tells you, well, what do you do? And you say, well, I'm a wheelman or I'm a refiner or something like this. You know, they look at you like, what's that supposed to mean? And I think the men are unique out here, too. I think there's a special breed of man out here. I don't say we're odd or anything, but we're different than a lot of people. You know, we've worked together for so many years now. You know, we're a lot like a big family.
There's a lot of great guys out here. Been a lot of great guys out here, and probably the thing I'll probably miss the most is the people I've worked with all of these years.
A lot of times we spend more time out here than we do at home with the overtime, and so I think you get a bond and you work with the guys, and I think that's the thing that makes it unique over other jobs, is the fact that the years that you spend and your tradition and the history that you have as your family members and that's worked out here in the past.
Now we have a new smelter. It took 3 years to design and engineer, and 2 years to build. It was the largest privately financed construction project in Utah history. And it's a testimonial to technology. It will process about 1,110,000 tons of concentrate and precipitate and produce about 310,000 tons of anode copper. Both of those numbers are almost double what the old smelter could do. The new smelter uses a flash smelting process to produce matte, which is then processed in a flash converting furnace. Kennecott engineers invented the flash converting technology. And this smelter will capture 99.9% of the sulfur contained in the concentrates. That makes this the cleanest copper smelter in the world.
Well, the old technology took a lot of muscle work. It was hot, dangerous, as I said, dirty, very stressful. The new technology is pretty much mechanized, pretty much automated.
In the old anode building down below, we used to, we'd cast the anodes. You know, we were using a stick, and we just pour each anode by our eyesight and what we were seeing. And up here, you know, we're using a lot more high-tech equipment. We're actually weighing each anode as we pour it.
I'm going on 18 years, and I will have seen 3 smelters in 18 years. So the technology's moving quick. I started in the reverbs, went to the reactors, and that was state-of-the-art at the time, and now we're going to this new one.
But this process at the new place is going to be totally different. They're going to have it done, I don't know how many more tons a shift. It's going to be just a copper-making machine.
In the old plant, we had control room for, we had an operator for each of the converters. We had a control room for the reactor, control room for the anode wheel. Here we have one for the anode wheel, and then one control room for the entire smelting, the feed, both smelters. So that's quite a bit different. In the 31 years I've been here, I've gone through about 4 smelters now. And so we've gone from Larry cars on top of reverbs to this new process they got today. So we've gone through quite a few different changes. And almost any kind of smelting that's been available in those years.
Now this new smelter is, the company has made a real effort to do this right. They spent a lot of money, a lot of time and effort in training the guys and getting good equipment, and the new smelter is a good job.
Perhaps it was the lure of working around hot metals, of sensing the immediate danger. Or maybe it was just because working at the old smelter, any of the old smelters, is a distinction claimed by a fairly small group of very special operations and maintenance people. Whatever the reasons, the smelter seems to spawn a camaraderie among its employees that is difficult to find in other places or other lines of work.
Just gets in your blood, you know, smelter people, they're different people.
Henry Pistorius, I can remember him taking me over by the reverbs and saying, you know, I said, God, there's a water leak coming out of the ground here. And old Pistorius would tell you, well, that's a natural spring. It's been here forever, and the Pony Express used to stop and water their horses here. You know, and it shows up every spring. Find out now it's an underground pipe that had busted. You know, you just didn't want to fix it.
A few years ago, when we got so cold, we lost all our heat in the filter plant, and we shut everything down, and all the belts stopped, and the concentrate froze on the belts, and we ended up taking the concentrate off with hammers in chunks, and we were down for a couple of days. So it was so cold, we didn't have any heat anywhere, and the guys really worked together, and so.
There's been a lot of good people over here and a lot of good things done. And a lot of guys work together real well to make it work.
Do you still have the sloping mouth liners?
Yes, that was the best thing I ever did.
I don't want to, we started that up on the new converters, them sloping mouth liners, so that they wouldn't bang them out with that big ram.
And you know what else you and I did was The last 2-foot section of those rolling door hoses, we went
Yes.
to that short section, that still saves us.
Is that
It's
right?
changing that whole hose out.
That was a hard job to do, is to get those guys in a basket and get up there on an operating furnace and try to plug up some of them holes in the water jackets.
The way we've worked together all through the years. You know, when we started this place up, this anode that we're in now, you know, we really had to work together, you know, and work side by side, and it was pretty fun, you know, of getting it going and getting all the bugs out of it when we did. And there was a lot of work that really had to be done, and we all dug in and did it. You know, we learned a lot, and I like to think that we taught some people some stuff out of it too.
Technologies change. Systems and methods of doing things change. So do equipment and physical plants. Eventually, just about everything around us will go through some sort of change. But there's always one constant in a time of change: people. Garfield smelter rats have seen it all through the years, and since 1906, they've performed the occasional miracle. Technological advances don't mean much without the maintenance people to keep the plant operating. When it seems like the job just might be impossible, Kennecott people get it done. In some cases, that ability could be genetic.
He hired like the year I was born. Okay, I think he hired in '60.
I started February 22nd, 1960. I had an uncle that worked out here. He was the one that actually got me interested in coming out here. And he retired about 20 years ago.
My dad was out here for 28 years, and he got me on. But he didn't want me to get on out here. He said, "No, I don't want you to go to that place." But, you know, just out of high school, I think, well, I'll try it. And I'm still here, 25 years later.
I am the third generation of the Sankovich family, okay? My grandpa worked for the Nevada mines for 49 years. I had 2 uncles that worked 147, 146, and my father was 44. So I'm the low one there with 40. And I also have a son working in the mines. You know, he'll be the next generation to carry the tradition.
My dad was out here, and he retired after seeing 3 smelters after 43 years.
My grandfather was William B. Heyman. He was an engineer on the Bingham and Garfield Railroad. His brother Frank, F.O. Heyman, was the superintendent of that railroad. But my grandfather was the engineer on the first train of ore out of Bingham on the B&G, 1911. In fact, that train ended up clear over here and out in the flats because they couldn't stop it. So anyway, he worked here all his life, and my father started here in the smoke test department and then went over to the railroad a couple of years after that.
From all the way to my grandparents, at one time I had my mother and my brother working here in the reactors with me. My dad and my sister worked over at the refinery. My dad's retired from the refinery. My sister still works at the refinery. I've got brother-in-laws all through the mine, all through the Kennecott system. Yeah, we're pretty well Kennecott family out here.
As we enter the new flash smelting, flash converting era, let's take one last look back at the smelter that kept us competitive through the last couple of decades. We'll never see anything like it again.
I enjoyed it. I've enjoyed every day I've been out here. You know, of course, there's been days, you know, where I wish I was anywhere but here, but in general, I like it.
A lot of good camaraderie. There's a lot of really highly skilled people, you know, that we've all worked together and joked together, and it's been good. It's been a good experience.
I'm a metallurgical engineer, you know, by study, and I mean, that's kind of sad to miss that. I mean, that's what kind of got me into metallurgy. You know, the fire and it's kind of dark, and it's kind of an old world type of thing, medieval almost. That's a piece of history over there.
Yeah, I'm going to miss the old smelter. I miss most of the guys when I leave. But
Because I'm a creature of habit and I'm used to the routines of the old smelter, and I'm going to have to get used to the routines of the new smelter now.
We've had some good times out here, and I hate to see them go. Great bunch of guys to work with.
I think I'll miss a lot of the people and a lot of the jobs over here that we've worked to make them good jobs, you know, and we've done a good job with them. And yeah, it'll be, you know, you work all those years to create something like that and help with it and work with it, and it's tough to see it go. Yeah, I will. I think I'll miss it. I'm sure I will, but not too much.